Okay, this lecture is about Fourier series. So we have a function f of x which is defined on the interval minus L to L, and you can think of f of x is a continuous function or even maybe a piecewise continuous function. We will expand f of x in terms of sines and cosines. So we'll write this as a sum for n from 0 to infinity a n cos n pi x over L plus bn sin n pi x over L. The sines and cosines we have defined here from 0 to L, and we have, that is why written n pi x over L. We can immediately see that perhaps n equals 0 is a special case term. So if I set n equals 0, sine of 0 is 0, so second term will be gone. Cos of 0 is 1, so we will get a0, and the rest of the thing I can write from n equals 1 to infinity a n cos n pi x over L as is, and from 1 to infinity bn sin n pi x over L. One thing you can notice is that this first part, or maybe you can say first two term, this is like cos, because if I take a0 to inside the sum, that will be cos. So I will say, okay, this part is a cosine series, and this part I will call it is a sine series. Okay, so before looking at sines and cosines, so we can perhaps think of rewriting this long series into some short form. So we go from n from 0 to infinity, and I can see that these sines and cosines perhaps can be combined together somehow if I adjust the coefficients or choose the coefficients in a way, e to the power I n pi x over L, or maybe I can just think of generic constant Cn and a generic function phi of nx, and maybe I can say phi of nx is e to the power I n pi x over L. Okay, so then e to the power I n pi x over L will give us sines and cosines. So basically we are looking at the function in terms of sines and cosines. We have seen here is that this part is a cosine series and this part is a sine series. So for instance, we can say neglect the sine part, so set all the coefficients b to 0, and then I will have the cosine series. Or if we set all the coefficients a to 0, and then I will have the sine series. Maybe we are worried about when to choose a sine series or when to choose a cosine series, and so on. One thing you can look at is that this sines function is an odd function and this cosines function is an even function. So if my function mostly looks like an even function, then I would expect that this function does not have much like sine, it might be much like a cos. If my function f of x is like an even function, or it is an even function, then I would expect that it is a cosine series. Similarly, if my function f of x is an odd function, then I will expect that it looks like sines. Okay, So having said that, maybe I can give you an example to understand this behavior a little bit. So I will take a function f of x, which is 0 on this interval from 0 to 1, and it is 1 on the other interval from 0 to 2. Okay, so it is very simple function, and we want to first sketch this function. So if I sketch this function, for example, I go, this is 0 up to 1, and then I just jump to 1 and go up to 2. So 0, 1, 2. So this function here from 0 to 2, I don't know whether it is odd or even, or maybe I know it, but I can just think of extending this function to the whole real line. And in order to extend this function, I will just flip this function with respect to the y-axis. So I will come back here, this part, to -1, and this part up to -2. Okay, now I have this function extended from L equal to -2 to L equal to 2. And this function looks like an even function. It's because if I take anything for the positive part and anything from the negative part is the same. Or if I just fold the paper on this vertical line, they're superimposed. So this is, I have extended this function in such a way that it is an even function. Now you can see that I could have extended this function in a way that it looks like odd function. We'll come back to that odd function later. Now what I will do is that I will continue extend this function periodically. So I will bring the whole thing and put it on the right side. So it will look like now so say 2, 3, 4, 5, and so on. So I can I can repeat that to the left. So this is an extension, even extension, and then I have extended periodically. So I can say that it's a even extension periodically. So I will say f if x is an even extension with a period of 4. And since this is an even function, I can write a Fourier cosine series. So I'll go from n from 0 to infinity, a n cos n pi x over L. Or I will say, okay, a0 plus sum over n from 1 to infinity, a n cos n pi x over L. So we don't try to memorize those formulas. Rather, we like to see, okay, the function is an even function. When I have extended that, like an even function, and it has a period of 4. So it is going from -2 to 2, and on that particular interval -2 to 2, it is an even function. So this function, extended function, will be a Fourier series, I hope Fourier series converges to that function. That's my hope, but I'll discuss later on to show or to understand when it converges and when it does not converge. So for now, let's assume that the Fourier series has converged to this function. So I will say, okay, so this is a sketch of Fourier cosine series. So this plot is a sketch of Fourier cosine series. Let me write it down. Fourier cosine series. So similarly, if I have a function given in an interval, any other function, I can extend it periodically as an even extension, and that will be a visualization or a plot of Fourier cosine series, because that even function I can extend in cosine series. Or I can go back and say, okay, I have a function given on a particular interval. I will extend the function as an odd function periodically, and then I will identify the period, and then I will write this function, expand this function as a Fourier sine series, and I will consider the sketch of the extended function as a sketch of the Fourier sine series, or a visualization of the Fourier sine series, hopefully with a strong hope that the Fourier series converges, as long as we have many terms, or we have gone up to infinite number of terms. Thank you very much.